This is a little tutorial to help you understand how to do sig figs with mixed operations. This is an example from someone's homework problem that they asked me about. So we've got, supposed to be a laser pointer. Oh, okay. 2.45 times 10 to the 6 divided by 47.116. So we'll do that on the calculator, and this is what the calculator will tell us. Now we need to think about, well, if this was the final answer, how many significant figures would this have? Well, this is division, so we're going to look at the first number and say, well, how many sig figs does that have? Well, that one has 3 sig figs. And then we look at the other number, and we see that it has 5 sig figs. And the rule for multiplication and division is you pick the smaller. So 3 sig figs it is. So we start over here, 1, 2, 3. This is our last sig fig. So I'm going to underline that. Now, if we were going to round the number here, we'd have to put it in scientific notation, but we're not done yet. All we have to do is keep track of the sig figs. Because next, we're going to add 148.84. 148.84. That's not a 4. There we go. So when we're adding, we're looking at fewest decimal places. Because this number is really big, the uncertain digit is to the left of the decimal point. So saying number of decimal places doesn't really help us out. What we want to do here is identify the uncertain digit in each of these things, and then do the addition. I should do this on a calculator, but I don't have mine with me. You'll excuse me if I did the math wrong. So this value has uncertainty in the hundreds place. That means that we're not certain about this digit. So then we're not certain about this digit either. I'm going to underline that because that's an uncertain digit. This number is more precise. The uncertainty is over here in the hundredths place, the second decimal place, meaning that this digit is uncertain. Oops, I accidentally undid my underline. What we're really looking for is which one has the largest uncertainty. So this uncertainty is much larger than that uncertainty. And so this one's going to win. And this is where we have to round our number. So 521, I can't leave it at 521 because it's actually 52,000. So I can replace the digits before the decimal point with zeros. This is not the best thing to do. The best thing is to write this number in scientific notation. So it's going to be 5.21. The next digit is 4, so I'm not rounding up. And that's where I want to stop, so I'm not going to write down any more digits. I'm going to go straight to times 10 to the, and I'm going to look at how many places did I have to move the decimal point. 1, 2, 3, 4. The exponent's 4. And we ask ourselves, is it a big number or a small number? Well, 52,000 is a big number. How does Mrs. K feel about big paychecks? She feels positively about them. So this exponent is positive. So this is the answer. These kinds of questions are tricky. The good news is that beyond this chapter, we won't run into them very much. Please text me if you have questions.